Jai Hind to all. My name is Aditya Shankarav Deshmukh. I am studying in B.SC second year in Adarsh College Hingoli. Today we are going to discuss partial differential equation which is non-linear in P and Q. Let us discuss what is non-linear partial differential equation. If the dependent variable and all its partial derivatives occur linearly in any partial differential equation, then such an equation is called as linear partial differential equation. Otherwise, it is called as a non-linear partial differential equation. In this session, we are going to discuss non-linear partial differential equation of type 1, in which equation of the type f of p comma x is studied. That is, equations containing only p comma q only. Let us discuss how to solve such equations. Let the required solution be z equals to ax plus by plus c. There, del z by del x equals to a and del z by del y equals to b. On putting this value in f of p comma q equals to 0, we get f of a comma b equals to 0. From this, we can find the value of b in terms of a and substitute value of b in z equals to ax plus by plus c. This will give the required solution. Let us discuss some problems based on this method. Solve p square plus q square equals to 1. Let z equals to ax plus by plus c, considering this as equation number 1. Therefore, del z by del x equals to a and del z by del y equals to b. We know that del z by del x equals to p and del z by del y equals to b. That is, p equals to a and q equals to b. Equation 1 becomes a square plus b square equals to a 1. From this, we can find the value of b square, which is 1 minus a square. Now, taking square root on both sides, we get b equals to plus or minus root over 1 minus a square. Now, put value of a and b in equation number 1, that is z equals to ax plus by plus c. We get z equals to ax plus or minus root over 1 minus a square into y plus c. That is the required solution of given problem. By this method, we can solve non-linear partial differential equation of type 1. Thank you friends for watching this video. Jai Hind.